Which of the following minerals cannot be scratched by a piece of quartz or by a piece of apatite? Alright, so here, we have to figure out exactly where is quartz. So when we look at quartz, what is the hardness level of quartz? Great job. It's 7. What about apatite? Great job. It's 5. So in this case right here, in order for it cannot be scratched by quartz, it has to be harder than that. Okay? Because as soon as it's not as hard, immediately you can scratch it. For example, gypsum can scratch talc, calcite can scratch gypsum, fluorite can scratch calcite, and so on. So the harder you get, the more you can scratch lower. So if it cannot be scratched by quartz, it has to be harder than that. So out of these, which ones could be your options? Which ones are harder than quartz? Anything more than? Exactly, anything greater than 7. So 8, 9, or 10. So your only options here would be either topaz, corundum, or diamond. So let's go to our answer choices. Which one here is going to match? Great job. Topaz would be the correct answer because topaz is the only one in this list here that is harder than quartz. So quartz cannot scratch it. Let's go to number 7. The graph below represents the motion of a car. So we have to look at this graph carefully. We have to see what we have here. On this side we have distance right here in kilometers, and here we have on the x-axis time in minutes. So the question asks, what is the average speed of the car? Alright, so we've talked about this before. So if it's asking for speed, we know it's S equals question mark, because we don't know what that is yet. So now we know we have distance here, so we have to have a d here, d equals something, and then we have time here, so we have to have t equals something. So we have a lot of different points here. Which one do we use to get the average speed when using this graph? Great job. We're going to focus right there in that spot. So what is the distance right there in that spot? Great job. The distance there is going to be 4 kilometers. How much is the time right there in that spot? Great job. The time right there in that spot is going to be 10 minutes. So remember, you work your way down this way and that way, right? So you get your distance and your time. So then you go to your formula, try and figure out, okay, which formula do I have to use here? So we're using speed equals distance divided by time. So you make your triangle, multiplication at the bottom, division on the side, I on top for inside the house, O at the bottom for outside the house. So since we have the D here on top of the T, we put D right up here, T down here, and our S, and we have our triangle. So now we have our numbers and we've set up our triangle. Now we can redo the triangle, this time actually plugging in those numbers that we're using. So we make the triangle again. Make sure you still put your symbols. Speed is still question mark, so we put that there. Now we know distance is 4 kilometers, so 4 on the top. We know time is 10 minutes, so 10 right here. So 4 goes inside the house, 10 goes outside the house, and we can do our division here. Can 10 go into 4? No, we can't, so we put a 0. We had our decimal and a 0 here. Can 10 go into 40? Yeah, it goes in 4 times. So 10 times 4 is 40. 40 minus 40? Great job, 0. So in this case, our average speed is equal to 0.4, and don't forget the unit of measurement, kilometers per minute. So your correct answer would be letter A. Now if you had done it incorrectly, which does happen very frequent, where you want to put automatically the bigger number inside the house all the time, you would have actually ended up with 2.5, which is letter B. So you need to be very careful that you set up your triangle exactly the way it should be, and make sure you put the correct number inside the house, even if it's not always going to be the bigger number. Let's get the next one. Number 8. What causes currents in the atmosphere? So we have to remember what a current is. A current is a movement of something. So we can have electrical currents, so the movement of electricity, those electrons. We have currents with heat, for example, let's say you have boiling water, for example. So it's currents in the water, and they're consistently moving. The water is moving around. So in the atmosphere, we have a bunch of gases. So with those gases, since they're like, kind of like air, right? So we're trying to figure out exactly what is happening in this atmosphere. Why are there currents? Why are things constantly moving? So it's just like when we talked about convection currents with water, it's the exact same thing here. One of them has to go up and the other has to go down. So because the Earth is tilted at an angle, the Earth is always heated unevenly by the sun, because part of the Earth sometimes is a tiny bit closer to the sun than another part. So because of that, there's areas that are hotter and there are areas that are a little colder. They're not as hot. So we have to remember which one is the one that goes up and which one goes down. Great job. So our warm air is the one that rises, and our cold air, because it is denser, will sink. So in this case, the correct answer would be letter F. Now, when the water evaporates from a lake, yeah, it's obviously warming up, so it's going to go higher, so eventually it'll go up. But it's still the fact that the water evaporates doesn't cause the movement in the air in the atmosphere. But it is the actual heat there that is going up because it's less dense, and that's when you feel that movement of the air. The pull of the moon's gravity, that has nothing to do with the currents in the atmosphere. That actually just deals with the tides, the ocean tides. So, when the moon is at in a certain phase, the tides are greater and higher and so on. And then the movement of the Earth around the sun, all that gives us, it's a revolution, so it gives us our seasons. That plus the tilt gives us our seasons. So let's get the next one. Number 9. Sarah was taking a walk with her friends. She looked down and saw 2 unknown minerals. When she dragged them across the sidewalk, she noticed that they produced the same color mark, but one scratched the other. What conclusion could Sarah draw? Alright, so we're trying to figure out, exactly what is going on here. So you have 2 different minerals. So we're going to say we have mineral 1 and we have mineral 2. So it says here that they produce the same color when she scratched them. So when you're scratching them against the sidewalk, or dragging them in this case, not scratching, sorry, dragging them across the sidewalk, it's going to leave a certain residue. What kind of residue does it leave over? What does it look like? Great job. It's going to look like a powder residue. So in this case, it's a streak. So in this case, they both have the exact same streak. Alright? It's the exact same streak because it's the same color mark. However, one scratched the other. Now we don't know which one scratched the other. We're going to pretend that it's mineral 1. So we would say that mineral one is harder and mineral 2 would be softer. So one is harder than the other. So now we can draw our actual conclusion based on this. So let's look at letter A. Letter A says their hardness and streaks are the same. Is that true based on what we saw there? No, it's not. The hardness is different. Letter B. Their hardness is the same, but the streaks are different. So are the hardness the same? Is the hardness the same for both of them? No, remember one right here is harder than the other. And the streaks are actually the same, not different. So it's not letter B. Letter C. Their hardness is different, but their streaks are the same. Is the hardness different according to what we wrote down after we read the question? Yeah, hardness is different. What about the streaks? Are the streaks the same? Yeah, the streaks are exactly the same. That's what we wrote down. So far C looks like our right answer. But let's take a look at letter D just to make sure. Letter D says their streaks are the same, but their luster is different. So are the streaks the same? Yeah, according to this, the streaks are the same. Luster is different. Now, luster, what does luster talk about? Good. Luster determines how shiny or dull it is. So how much light is actually reflecting on it, right? So in this case, in this question, does it say anything about how shiny it is or how much light reflects off of one mineral compared to the other? No, it doesn't. So D can be our answer, leaving us with the only option of C. Let's get the next one.